Imagine you're the CEO of the busiest company in the universe. No, not a billion-dollar company, a CPU. Every second, people click buttons, open apps, watch videos, play games, and type messages, and every one of those actions creates new instructions. Your job? Handle all of them. Meet Mr. CPU, the world's most overworked Stickman CEO. The moment you turn on your computer, requests start pouring in. Open the browser, play the video, load the game, check my email. Poor guy doesn't even have time for coffee. Here's the important part. A CPU doesn't understand websites, videos, or games. It only understands tiny instructions. Really tiny. Things like add these numbers, move this data, compare these values. Simple tasks, but there are billions of them. Every click you make can trigger thousands or even millions of instructions behind the scenes. So while you're casually opening a cat video, your CPU is running a massive office trying to keep thousands of tiny jobs moving in the right order. And that's just the beginning of the chaos. So how does our poor CPU CEO survive all this chaos? Simple. He hires specialists. Imagine trying to run an entire company by yourself. Answer emails, do the accounting, manage employees, deliver products. That would be a disaster. So, instead, our CPU CEO creates departments. First, there's the Control Unit. Think of it as the office manager. It doesn't do the actual work. It tells everyone else what work to do. Hey, you process this, you move that, you handle this request next, keeping everything organized. Then there's the ALU, short for Arithmetic Logic Unit. Fancy name, very simple job. It's the office math nerd. Need to add numbers? That's the ALU. Need to compare values? That's the ALU too. Need to decide whether 10 is bigger than 5. Believe it or not, ALU again. While the Control Unit directs traffic, the ALU handles calculations and decisions. Together, they turn a mountain of tiny instructions into actual results. And the best part? This office isn't handling just a few tasks, it's doing this billions of times every second. No coffee breaks, no weekends, no complaints. Well, mostly no complaints. So now our CPU office has departments. The Control Unit is managing traffic, the ALU is handling calculations. Everything looks organized. Problem solved, right? Not quite, because the office still needs a system for handling every single instruction, and that's where the real magic begins. Imagine a giant filing cabinet sitting next to the office. This cabinet is called memory, or RAM. It's packed with instruction cards waiting to be processed. Every few billionths of a second, the CPU starts a simple three-step routine. Fetch, decode, execute. First, fetch. A worker runs to the filing cabinet and grabs the next instruction card. Maybe it's add these numbers. Maybe it's move this data. Maybe it's compare these values. Nobody knows yet. They've just fetched the instruction. Next comes decode. The Control Unit reads the card and figures out what it actually means. Ah, this is a math problem. Send it to the ALU. Or, this is a data movement task. Send it over there. The instruction is now understood. Finally, execute. The right department performs the work. Numbers get added, values get compared, data gets moved. Task complete. Then the CPU immediately grabs the next instruction. Fetch, decode, execute. Fetch, decode, execute. Again and again and again. This tiny office assembly line runs billions of times every second. So while you're opening a browser, watching a video, or launching a game, your CPU is racing through an endless stream of instructions faster than any human office could ever dream of, and it's all powered by one simple cycle. Fetch, decode, Execute. Now here's the problem. Even with our amazing Fetch Decode Execute assembly line, one office can only do so much. What happens when you're watching a video, listening to music, browsing the internet, and somehow still expecting your game to run smoothly? Poor Mr. CPU would completely lose his mind. So engineers came up with a brilliant solution. Instead of building one giant office, they built multiple offices. These are called CPU cores. Think of each core as its own mini-office with its own workers, desks, and assembly line. Now, instead of one CEO office handling everything, there might be 4, 8, or even dozens of offices working at the same time. One core might be helping your game, another might be loading a web page, another could be handling background tasks you don't even know about. Suddenly, the workload gets shared, much less panic, much less chaos. But modern CPUs have another trick: cache. Imagine workers constantly running back and forth to the giant RAM filing cabinet. That takes time. So the CPU keeps a small supply cabinet right inside the office. This cabinet stores information that's used frequently. Need the same file again? No long trip required. Just grab it from the nearby cache. It's much faster. And when you combine multiple cores with super-fast cache, you get the incredible CPUs inside modern computers, phones, and game consoles. So while you're casually opening apps, watching videos, chatting with friends, or playing games, tiny Stickman offices are working together behind the scenes, processing billions of instructions every second. And that's how a CPU actually works.